Welcome back, Calc. We are on 6.6b, and what we have is a problem where we are going to need a calculator for, and we have this context right here. Make sure you do read the question though, because there's definitely an important statement right here. At t equals 0 minutes, the temperature of the biscuits is 100 degrees Celsius. Also is worth mentioning that those are your units, and we have b prime of t, so that is a rate, and they tell you it's a rate. So as I mentioned, this is pretty important to understand that at 0 minutes, we're starting at 0 degrees Celsius. I almost wrote down Fahrenheit. So if I ask you for the value of b prime of 3, this is just pretty straightforward. Now what I would do is go straight to my calculator. You can see I haven't changed my calculator at all. Where I go to y equals, whoops, wrong button, y equals, clear that out. I'm just going to type in that equation. Now make sure when you use your calculator, because I make this mistake a lot, you use the negative key when you need it, negative 13.84 e to the negative 0.173 t. And double check that you typed it in correctly, because if you didn't, you'll definitely get the wrong answer. So if I ask for b prime of t of 3, on the home screen I can just hit alpha trace with parentheses and just plug in 3 right there. I can see that I get negative 8.236. And the units, because it's a rate, is degrees Celsius per minute. And that is the rate that the biscuits are decreasing at t equals 3 minutes. And just for perfect context, you know I'm going to show you the answer. At exactly 3 minutes from being removed from the oven, the temperature is decreasing, because it's negative, at a rate of 8.236 degrees Celsius per minute. So then from there, again, I would anticipate students using a graphing calculator with this. We can use the graph and explain in the context of the problem why the graph makes sense. So if I just go to the graph, let's see, they want from 0 to 11 minutes, it looks like, so I would change my window. Maybe I'll do negative 1 to 12 and hit zoom 0 to fit into the screen. Maybe I'll change my window to go up so I can see the x-axis. Maybe make it up to 1. There we go. That might make a little bit more sense. That we have this kind of answer. Where's negative 6? 1, 2, 3, 4, 5. Holy cow. I don't really like how this graph is drawn, but looks something like this. Now, why does this graph make sense? Because b prime is the rate, it's decreasing in temperature fastest as soon as it gets out of the oven. So it's the most negative as soon as it comes out of the oven, and I guess the temperature is still decreasing because it's negative, but at a slower pace. You can write down what you feel is a good answer. Otherwise, you can copy down what the answer key says. It's the rate at which the temperature of the biscuits is changing. So after the biscuits are removed from the oven, the temperature must always decrease. I didn't say that, but maybe you did. So b prime must always be negative, less than 0, and it's always below the x-axis. So in the next part, at t equals 10, what is the temperature? Well, remember we have that initial condition at b of 0, and then we can work from there, from 0 to 10 of b prime of t dt will get me to b of 10. And again, I'm a big fan of just writing things out, and you don't have to rewrite that this number is 100. because that'll be evident in your final answer. But when you go back to your calculator, quit out of this, you can just do 100 plus math, the ninth option, from 0 to 10. Alpha trace that equation in terms of x, hit enter, and you'll get the correct answer, that it's 34.183 degrees Celsius. And again, if you prefer a little bit more work, by all means, definitely can work it out. Completely up to you what works best for you. I also am not really that big of a fan of how he wrote it, but he is correct. Adding 100 to the left side, subtracting, but the symmetric property and things like that. So if you prefer his work a little bit better than mine, they are both equivalent. So as I move on to I believe this is my last example. Again, definitely worthwhile to mention all of these directions. So during the first 5 days of a 60-day period, 3 millimeters of rainfall has been collected. And then we're starting from 5 to 60, where the rate looks like this. So find the value in this problem. I'm going to assume based off of these contexts that we can use a calculator, although this is actually a problem you could probably do without. But anyway, if we were tasked with doing this, one thing you could do as well is figure out what S of 15 is and S of 10. But I think we're going to just need a calculator for this. I guess I should point out that you could do this because we do know the antiderivative of sine is negative cosine. We'll cross that off still. Negative cosine of 0.03 t. I also have to think of the chain rule here. Let me move this in front. 0.03. And what I'm doing is I'm undoing the chain rule because I'm thinking about, well, the derivative of cosine would give me, the derivative of negative cosine would give me positive sine. You would leave the inside alone, but then you'd have to multiply by the derivative of the inside. So that's why, working backwards, I divided by that, plus 1.5 t, and that would be from 10 to 15. Let me see if the answer key does that or if he just uses a calculator. Yeah, looks like he just used a calculator. So at this point, I'm going to trust that you could do that. However, you can go to a calculator and do the integral from 10 to 15 of s prime of t dt. And that represents the amount of increase in the height of the water level in the can from t equals 10 to t equals 15 days. Notice that every time that they were measuring it was in days. There we go. At the end of the 60-day period, what is the volume of the water that had accumulated in your can? Well, remember, we had a starting point that wasn't at 0, but it started at 5. And then what we can do is the integral from 5 to 60 of that s prime of t dt. And since the author of this went ahead and used the calculator, I'm going to trust that you can use a calculator. So I'm going to let you go ahead and plug that in, see if you get the same answer. So you can hit pause right now. Write down your questions if you have any. Otherwise, I'm going to show you the answer with the answer key. So notice that it started at a height of 3 at s of 5. Oh, I didn't answer the second part about the volume. Sorry about that. I guess we need to go back and figure out that volume is the formula pi r squared h. So if the radius of the can was 10, we could then figure out this answer as well. Okay, then this last problem, I think, right before your notes, I think I'm just going to stick on the answer key here, is we have the rate at which people enter an auditorium for a concert is modeled by this. And notice that just because they tell you it's a rate, that's all you need to know. It does not have to say R prime of t. And you even know it's a rate because it measures it in people per hour. All right. So VIP tickets are sold to 100 people who are already in the auditorium when the doors are open. So think of R of 0. I shouldn't say it that way because R of 0 is from this equation. So the antiderivative, the starting point would be at 100. And then we want to figure out this question, and I can already tell what the question is based off the answer. If all of the VIP ticket holders stayed for the start of the concert, how many people are in the auditorium when the concert begins after 2 hours? So since we start with 100, it makes sense to say 100 plus the integral from 0 to 2 of the rate equation. And you could just write R of t dt instead of rewriting this equation. And you could do this without a calculator. You'd trust me on that. It might be difficult math because you'd have to do 1380 divided by 3 and 675 divided by 4. So maybe not without a calculator, but you could at least set it up. And sometimes they do that on a math problem. They might say set up but do not solve. But I would trust on this one. You could use a calculator to get to that answer. And it looks like we're ready for the homework once you get that jotted down. There you go. Yeah, homework's on the next page. 6.6. You have some free response questions, and we'll be ready for 6.7 after that.